Welcome to Pseudorandom.
Wow.
Wow.
What are we doing here?
You're impressed already. This
This
great.
is amazing. This 5 stars.
I was at home and then suddenly
Would watch again.
the intro fades away and I'm here.
Okay. Well, we teleported into this couch, this magical couch. Why it's so glitchy. And we're gonna do a
That
Pseudorandom.
explains it. I get it now. Yeah. Matter to matter, we're here. In other ways, light to sound. That's what I want to get to.
Okay. Well, last week
I'm not messing around. I'm going straight.
we're
straight
going.
to
Yeah,
it.
you really good for the kill. So last week we did color organs,
We did.
which was amazing.
We did. We sampled. I think we inspired some people, reminded them about the magic of color organs, or
Totally.
helped them discover it for the first time. But there isn't a magic that moves in the opposite direction.
Or is there?
It's debatable.
Okay.
Maybe there's a little more magic the other way. It's hard to say.
It's pretty magical.
Mainstream magic.
So color organs, you put your sound in, and it made this cool, colorful light show.
Mm-hmm.
But then musicians were not satisfied with that.
No,
That was not enough.
they wanted synesthesia in bidirectional.
The other way. So they wanted to convert light to sound,
Right, and they did.
and they did.
They did. Some talented engineers have built things that generate sound from light, or modulate sound from light.
Yeah, not like solar panels, but the light affects the audio. So do you
Yes.
by chance
Shape-
have any
shaping?
demonstrations?
Oh wow, I do.
Wow.
I brought a couple things.
This teleporter is amazing. It even brought demos.
It is. I have a couple fun things here. Let's see if we can.
Okay, do you want to go to the cover cam?
Yes, we can go to the hover cam
hover.
now. It's hovering above my
That's what it's
objects
called.
here. Yeah. Eric Archer is a very talented musician and engineer, and he didn't draw this eye. That's just a Altoids tin that I drew on. But this is his aptly named Super Light to Sound kit, and it has a photodiode and a bunch of nice filtration and tuning circuitry that basically allows you to hear light around you. Now, we're pretty much surrounded with fluorescence here, so it's not going to be too crazy to hear what's going on. We're just going to hear a bunch of clicks when I interrupt light. You can hear in sunlight sounds like wind. It sounds like a random noise. And then other lights like LEDs, like the PWM is just up in your face.
Up in my face.
Yep,
Okay.
you can hear PWM really clearly.
Do you want to turn this on?
And well, I think it would be more fun. We will hear what this sounds like a little
Okay.
bit. I promise.
Okay.
But
Okay, so can you have another example?
another board he made, this beautiful thing, is the drone matrix. I'm going to turn it around because this is the
Okay, so
orientation I'm
not
familiar
enough
with.
to do one light.
No.
Now there's is that a grid of 20 sensors? What's going on there?
This is a matrix of LEDs, which are basically they're pulse width modulated and sort of interfering with one another from horizontal to vertical. Let me demo it. It'll make more sense when you hear it. Make more sound.
Make more sense, make more sound.
Yep. See, we're making a lot of connections here in
Okay,
multiple
so that's
sensibilities.
Audio in.
So audio in. Probably gonna want some electricity there too.
Okay, you do need electricity for these things.
Okay, so you can see that's lit up. It's a little hard to see on the camera.
Okay, so that's
And
the
this-
matrix, and it's blinking very fast.
Blinking, and the reason why we're hearing sound is because this probe has this nice sensor on the end of it.
Oh, and you can
that was
kind of hear
pointing
this
down at it.
buzzing from the fluorescence.
Mm-hmm.
So yeah,
That's
there's this
the-
hum.
Yep, that's from the overhead fluorescence.
Okay.
So we bring it back down. And you can hunt around the matrix looking for your preferred reality.
And when you're tweaking the knob, is that tweaking the matrix or the synthesizer, or both?
That's tweaking the mod is tweaking the matrix. That's changing the rate of the flashing. And I'm moving around with the probe. And getting a lot of different sounds. It's a great sounding little board.
This sounds great. This is one of the nicest synths I've heard.
You can turn the switching off and really drone out, as the name implies. Yeah, it's a lot of fun. You can lose a good half an hour sitting with that thing.
That's great. This is a fun little kit.
Yeah, he makes great stuff.
Okay, cool.
Yeah.
All right, it would be so awesome if we had some sort of like artsy video that we could show.
Lady Ada,
Yes.
let me tell you what I can do for you. I can do an artsy video with
Colin,
some flashing
you never
lights.
disappoint.
I can intro with a little bit of grating noise that'll get rid of the non-believers.
Do you want to
Scare them all away. What, you want to watch it? Do you want to watch it?
I personally want to see this thing.
She wants to watch it. We should play the. Can we play the clip?
Hey. Okay.
Still with us?
I went
Good.
to another place,
You did.
but now I'm back.
That was the idea. You did run away for a minute. It was
No,
like
no,
a
no.
quick bathroom trip.
No,
In your mind.
These are lies.
Right.
I was physically always here.
Right.
Okay, so
Some people, the noise, the sound, it's
I
not
like
for them.
it.
I know.
I find it relaxing.
know.
Okay, so we have all of
Small
these things, and so the question is, how do they actually convert sound to light?
Right.
And you have a schematic for a really basic sound to light.
Right, the one that sort of, as far as I can see, sort of started it all.
Really?
With a
It's
lot
like the
of
Genesis schematic.
synth makers, circuit benders, and
Okay.
stuff like that. The Forrest Mims engineer's notebook from Radio Shack. Can we see that schematic?
Okay.
It was.
Light detector.
It was.
And
I
it was
mean,
just meant for light. He's like, this does not make music. This just makes a tone.
all things come back to this book, or these books, this series. It's so great. And it's a lot of fun with, what is it, like 7 parts or something like that?
Yeah, so you've got a 555, so it's
Mm-hmm.
going to be in a repetitive, it's a
It's a square wave.
monostable oscillator, whatever they're called.
The
And usually
speaker.
the frequency is set by, well, actually it looks like it's the duty cycle maybe is set by, I don't remember the exact pins for the 555, but that
The divider on
CDS
pin 4?
photocell, yeah, you see R3,
Right.
and then you see CDS photocell. And those two parts, maybe they had changed the frequency, the resistance, or they changed the duty cycle. But the photocell, what's interesting is it has a zigzag and then the arrows.
Zigzags and arrows.
Yes, you look at this.
They're visually interesting. Well, it's a resistor, right?
It's a resistor on the inside, but then those arrows are photons.
They are.
It's the opposite of
Those
LEDs.
are wavicles right there.
Wavicles. Well, when you have an LED symbol, it's a diode, but you have those arrows pointing out because photons come out. So this is kind of like the opposite.
Why are they jagged often on the LED? Anyway, it doesn't matter.
The jagged.
I'll get into those little.
Feynman diagram. I don't know.
Yeah,
okay, so you got this
things.
part called the CDS photocell. It's a cadmium sulfide.
Cadmium.
Yeah, we'll talk about that in a second. Okay, so you have some.
I have some. What do you know?
Let's
I
check
have
it out.
one of these. If we go to the hover cam here, which is hovering
Okay.
above my hand, this is a very familiar.
So let's check this out. So
Site,
it actually is
right?
squiggly.
It is squiggly.
That's kind of neat.
Kind of makes you think of resistance, and yeah, it's a pretty familiar site to folks around the electronics workbench. That too.
Okay.
And what gets me is you can get a bigger version of these. That kind of looks like the same thing.
I love it.
Just giant.
I gotta hold this up next to it. It's just like, hi, I'm
guys.
your friend.
I'm the big crazy caricature of that.
Yeah.
It's just funny that like oh yes, the squiggly works. We're gonna make a large squiggly.
And these are
like
very low-cost sensors. They're very
Yep.
simple. The more light hits them, I guess the resistance goes down. So it's just a
Right.
basic light to resistance
And they-
converter.
And they have a sort of, a little bit of a delay, like like a softness to them. How do you want to put that? A little bit. They're not super
When
precise.
the cadmium gets hit with the photons, or the cadmium sulfide, and the resistance changes, it isn't.
It takes time.
It takes a little time for it to change resistance. It's not
Right.
instantaneous. It slowly ramps up
Right.
and ramps down.
And that's a benefit in a lot of applications where you want it to be a softer response. Like a lot of compressors use what they're called optical compressors, audio compressors.
Yeah.
I mean,
Not
and-
data compression, but
not
like the
data compression,
audio, the
compression.
frequencies.
Right.
Yeah.
Right. And they will use, I believe they'll use these Vactrols for optical.
So
What am I trying to say?
light to resistance.
What is it? Isolated, opto-isolated.
Oh yeah, it's
Thank you.
isolated.
There
So
we
this
go.
is actually inside. There's
Oh, there we go.
this is a little black plastic piece, but inside there's a photocell.
And on the other side, there's an LED.
So it's like those optocouplers that you see in MIDI, but this is resistance output.
Right. And so Vactrol is just like the brand name. That's like Kleenex for opto-isolator.
Yeah, so I always thought it had something to do with vacuum
Discrete.
control tube or something when I heard the word Vactrol.
Right, sure,
I was like,
yeah.
oh, is it vacuum control? But it actually has nothing to do with vacuum tubes.
It's just a cool company name.
It's an
their brand
LED.
name.
It's a flat LED, and then it's right next to a cadmium cell right here, and then it's just epoxied. That's
Yeah,
it.
and it's easy to make your own by just epoxying an LED to a photoresistor and then just putting black tape around it or whatever. Did a bunch
Yeah, and
of
what's
those back in the
nice is
day.
that because the photocell, they're called photocells. I call them cadmium photocells are just called photocells. They're resistors,
Photocells.
so you can pop them into any circuit.
Right.
So any
Yep.
circuit bending that you want to do, if it has a resistor in it, you just get a CDS cell that's about the same resistance at natural light, and then it just acts like a resistor.
Right.
It's a slow resistor.
It's a great way to
that changes.
hack. I mean, like a guitar pedal or anything like this. You can just pop it right in and make a nice little custom fun control. For
There's
it.
only one problem.
What's that?
Well, other than that they look so cute, but they're not. They're made out of cadmium, which is a toxic metal.
There is that. ROHS non.
They're not compliant. So if you're in the U.S., because we are freedom-loving Americans, you
Freedom
can
for poison.
Yeah, freedom. You can buy, sell, and use CDS cells,
Right.
but in Europe you cannot.
Does this mean that the photocells' days are numbered, or are they going to stop making them? Or, I've read
think-
about that years ago.
yeah.
People are like, oh, buy them all up because they're going to disappear.
I think that there's still going to be them because there's enough. I mean, they're inexpensive. They're easy to manufacture.
We have made trillions of them.
They're,
and we're not
yeah.
getting a lot of
I don't
stock.
think it's going to be like Nixie tubes where like people are going to be on eBay like desperately. I mean, they're, again, I mean, we still buy and sell them because in America we just say they're not RoHS compliant. There was an exemption until 2 years ago for RoHS compliance for photocells, but that ended. Because I was looking this up because it wasn't initially, this is like silly details, but like when a RoHS came in like 10 years ago, they had an exemption for 5 years for cadmium, because there's so many people that were like, this is the one thing that we can't replace easily.
I can't use a photodiode for this.
Right, because photodiodes, there's no direct replacement. There's phototransistors and photodiodes, which act similarly, but they're current-based, not resistance-based.
Right, it's not an easy
it's actually on
replacement.
that thing, if you look at it on the overhead, it's not a photocell.
Which guy?
This one, the little...
Right, the probe here?
Yeah, so if you look at that probe, see how it's shiny and black? That's a piece of silicon, so it's a photodiode.
Oh yeah, it looks like a solar cell.
So, it's basically...
Photovoltaic.
It actually is essentially a photocell. And it just isn't as slow as you can't build a Vactrol out of it. But the person who designed the circuit, they just changed it so as long as it was current mode, it was okay. And that's how current optoisolators work. They don't use CDS photocells, they use a daub of silicon. And acts as it's actually an LED, essentially.
Silicon,
Yeah.
So, and this,
It's a PN diode.
this flat, they're not all light sensors we see that are flat on a chip like this are silicon, right? There are also like color sensors that use an array of photocells.
Well, actually, so this is like one gigantic chunk. So if you look at the
Right.
sensor that's in the glove video, I don't know if you remember that. That was like 10 minutes ago. Remember you did that color glove?
Right.
Demo?
Yep. It's all blurred, but I remember that spot. Yep.
So that uses the TCS color sensor. So you actually took a photo of that color sensor.
I did in a macro spree. I did see that
Yeah,
beautiful,
you had a little bit of macro
beautiful chip.
color. So this is it. We pulled it from your Flickr.
I think that was one of the first ones, and I'm like, oh, the lovely tiny world. Let's go back.
It looks like it's like Photoshop, but it's not. In the center there, you see how it says it's like red, green, blue, white, red, green, blue, white. It's a grid. That's actually 16 individual small versions of that photodiode or phototransistor.
Okay. So these aren't like cadmium resistive elements.
No, because like, how would you? It's too
was-
difficult to get that. You have to plate and like get this.
And you have to draw the squiggly line.
You have to draw a little squiggly line. Like, we're going through that. Instead, they actually just, when they made the silicon dye,
Yep. We got plenty of silicon
and then
here on
they
the chip.
actually
Let's do
like
it.
they painted it. Like when I say dye, the silicon dye is DIE. It's the chunk of silicon, but then they also put dye on top of the dye, and so it filters it. So you
That must get
actually.
confusing in the manufacturing process.
I wonder how many times they were like,
Yep.
"No, you
Not
gotta
the
do-
dye, the dye.
the dye."
Oh, it's all this ink covered with silicon.
And it also looks like above it, there's 4 normal photodiodes. The black looks like it's.
Like a luminance kind of thing.
Well, I think it does lux also, so just
Okay,
like plain
right.
light.
So, yeah.
So this can detect different. Maybe the white is an IR filter or something, or
Yeah, I was going to say the white. I'm like in the distribution of them. It's interesting. There's a lot of reasoning behind this.
I'm sure they
research and reasoning.
tried all sorts of things to figure out why. But yeah, you can tell that's the green sensor because it filters out only green light. It's like a gel. They basically glued a gel on top. So I think that's kind of neat.
Yeah,
the
it is.
solar.
I could stare a long time.
Yeah,
I
beautiful.
did actually. That's why I took that picture.
And this was just shot with an iPhone, right?
It was an iPhone 5. Yeah,
iPhone 5.
and then one of those
Amazing.
little hollow clip lenses.
Beautiful. What did you do to light it? Just like natural light?
I think that was an LED lamp that I was bending down at the table just next
cool.
to it. Yeah, tiny
Okay.
things, easy to light them in some ways. Yeah.
Yeah. Do you want to maybe show off this crazy glove? So you went farther than most. So most people just do on and off LED, but you built this project. Do you want to talk about what
Right.
this
Yeah.
is?
Well, it was an idea a little bird told me about, Mr. Phil, and it was pretty easy to put together with Flora and one of the audio codec boards. I always forget the call number though.
That's
the VS1053B.
Yeah.
And
You're using it in MIDI mode.
Yeah, MIDI mode, which is this awesome other ability of the board besides
really use
playing,
it.
besides the codec abilities, and it's like just sitting there, and I don't think most people really use it. And it's really easy. You just feed it MIDI notes, and then it plays MIDI notes right off
Okay,
the
so that's
top.
your audio output.
Right.
And then the Flora is doing the sensing. It takes the sensor data.
Flora is taking the sensor data, yeah, and converting it to MIDI notes and sending it over to the board.
The trade-off of these color sensors, which are basically just like 16 light sensors, is that it's not like a resistor. You actually have to like read the data and parse it. Like it's a lot more
Right.
complicated. You can't just like open up a synthesizer and solder this in and have it
Yeah,
work.
we're going digital here.
It's getting
different.
digital.
And of course, yeah, you've got the LED there to light the surface, which I'm sure you're familiar with that design since you designed it. And yeah, the NeoPixel on the back that represents the color that you're sensing.
Okay.
And
It's cool. Do you want to try it out?
I could try. I'm not totally sure how to work. Let's see. We'll just run it across some random things here.
Okay, you got your
Oh
4-inch to 1/8-inch adapter. Moved.
Oh yeah.
Okay,
yeah.
so now you're
Heavy
jacked
deals here.
in.
I'm jacked in.
We can
Yep.
make a version eventually that's Bluetooth that does Bluetooth MIDI, and then you don't have to have the
You don't have to be jacked in.
you don't have to use jacked in.
I jack in. It's okay.
That's cool.
I'm all right with that. So, if I turn my volume up.
Okay, so you got. So it's sensing the color reflected off of what you've got there. So you got green, blue, and red, and then it translates it into notes.
Yep, yeah. Right now I have it constrained to the pentatonic scale, the black keys. And that makes it really easy to just to play like a little melody that sounds pretty intentional. But in the normal mode that the sketch on the Learn Guide is written or has, it just goes through the scale, one segment of the keyboard. Yeah, it's a lot more fun to play when you have the full range of colors in front of you on a flat piece of paper. But
Like
it's
on the
interesting to
video.
experiment.
But this is, just proving it works.
Yeah.
Why-
See, I want to sit here. I want to like jam a little bit. That's the instinct. So that's why I'm saying these
Why
things.
do you think musicians love converting light to music? What?
Well, because it's so unpredictable.
You think that the pseudo-random chaosness of it?
I think there's a huge
the
element of
video.
discovery there. Yeah. And that's seriously, that's like a driver of why I'm interested in so many different things. But experimentation and discovery and blending elements is always a kind of almost like sort of mystical kind of edge to technology in some ways. It feels like frontier.
That's cool.
Does that make sense?
Yeah, no, because I see it a lot. I see a lot of people doing light to music, and I'm always a little curious, like why?
With so many, you can learn scales, you can learn all music theory, and then you can learn all the regiments of songwriting and all this stuff. There's a lot of structures that come into place, and little things that sort of square things off. And it's good to come at music making with a different approach and refresh it. So, I'm sure I could have, done arpeggios and stuff like that to make combinations that would create like a drone or something comparable to what comes out of the drone matrix here. But when I'm approaching it from this completely different way, I end up going into the just discovery mode. I'm like, there's no rules here. I'm just moving a little arm over these flashing lights.
It's like playful.
Yeah, and it brings you back to play. That's the way I see it.
Okay.
So you're not just like, that note doesn't belong there, or that's dissonant. And
The laws of
kind of,
yeah.
yeah.
There's like
lets
these
you
rule
break
sets
out.
that you're taught.
Right.
And then you get to break out of them.
Yeah, yeah. I think that's a big motivator.
Okay, that's so cool.
That's a good question. It's important.
I think that we've
We covered a bit.
explored.
Yeah.
We've deeply explored this.
That was fun.
Yeah. All right. Well, thank you so much for bringing these lovely demos. You always have a fountain of light, video, audio.
And thanks
Party.
for making me think at the end. I appreciate that. It's good. No, it's good.
Okay. Well, this was Pseudorandom. We got Pseudorandom there.
It's true. That was light to sound, and maybe another time we'll do sound to thought.
Okay. That's exciting.
Maybe not.
All right. Well, thank you everybody for watching this thoughtful video.
Be careful out there, and do things differently.
Don't forget to play.
Mm.